Welcome back. We will now shift into session 3 of the symposium titled AI and People, which will explore a range of topics in how artificial intelligence and robots interact with people in a range of environments, and conversely, the ways in which people interact with, utilize, and learn to optimize both functionally and economically the deployment of artificial intelligence. We will again hear from 3 speakers in this session, followed by a moderated conversation and audience Q&A. Our speakers in this session are Professor Daniela Rus, Andrew 1956, and Erna Viterbi, Professor of Electrical Engineering and Computer Science, and Director of the Computer Science and Artificial Intelligence Laboratory at the Massachusetts Institute of Technology. Dr. Rana el Kaliouby, Deputy CEO of SmartEye, co-founder and former CEO of Affectiva, and Executive Fellow at the Harvard Business School, and Professor Ajay Agrawal, Jeffrey Tabor Chair in Entrepreneurship and Innovation, and Professor of Strategic Management at the Rotman School of Management, the University of Toronto. And our moderator for the session is Professor Jonathan Zittrain, George Bernice Professor of International Law and Vice Dean for Library and Information Resources at the Harvard Law School, Director and Faculty Chair of the Berkman Klein Center for Internet and Society at Harvard University, Professor of Computer Science at the Harvard John A. Paulson School of Engineering and Applied Sciences, and Professor at the Harvard Kennedy School. It is now my pleasure to pass the virtual floor to Daniela Rus.
Hello, everyone. I am so delighted to be here with you today to discuss one of the central topics that will decide what our collective future looks like. Now, in my role as the director of CSAIL, I'm often asked to talk about the impact of AI. What will rapid advancements in this technology mean for our lives, our jobs, our futures? Well, AI is central to much of our work and our research, and I'm very optimistic about the future. I believe AI will improve our lives in many ways, some of which we've only begun to imagine. But my optimism rests on the belief that we, as educators, business leaders, policymakers, we have the ability to take action to control the challenges that this technology can create. And I'd like to highlight some of these opportunities and challenges. Let me begin with the good news, because there is so much of it. So remember when Spock shows up as a hologram in Star Trek in around 2300? Well, the good news is that you don't need to wait till 2300, because we have AI tools that support rapid holographic generation. So next time we have a virtual meeting, we will see each other in 3D. And remember when Mickey Mouse summons the broomstick in The Sorcerer's Apprentice? Well, you don't need magic to make that happen. You need robots and AI. And in fact, recent research in human-robot interaction, and more generally in human-machine interaction, is enabling machines to adapt to people rather than the other way around. So here's a robot that learns how to be a teammate to help a worker install a cable. And the way the robot knows to respond is by monitoring the muscle activity of the human. Now, we are really imagining extraordinary opportunities in human-machine interaction. And ultimately, we might ask, can we get to the point where machines can actually read our brainwaves and really understand what we want? And the answer to this question is very complex, and in a nutshell, it's no. There's too much complexity in that in the brain activities that can be detected by simple sensors like the caps you have seen. But we have made some progress in this respect as well. And in fact, there is a signal that our brain makes that we can detect using advanced machine learning. This is the signal our brain naturally makes when something is wrong, when we notice that something is wrong. And it doesn't matter what language you think in or what language you speak. This signal, called the error-related potential, is generated by everyone. It has a unique profile, and it is localized. So in this video, you see an example of using this idea to correct a robot's action. The robot in this picture is trained to sort paint can in bins labeled paint and wire spools in bins labeled wire. A human is watching the robot perform. When the human notices a mistake, the EEG cap that the human carries detects, oh, that was wrong. And that signal that can be detected in about 100 milliseconds is enough to reach the robot and tell the robot to do something different. So here's the video that shows you the robot putting the paint can correctly. But now the robot tried to go to the spool, and the human said, no, that's wrong. And here we go again. The paint is dropped correctly, and here's the spool going to the wrong bin, and the human through its brainwave activity has managed to correct the robot's mistake. So this is the ultimate human-machine interaction. I would say that the idea is fairly new, fairly preliminary, and we have a long way to go to where we have intuitive human-machine interactions, but we are making great progress. And we are making extraordinary progress with developing these kinds of tools and integrating them in our environments, and enabling us to even carry those tools with us so that we can have intelligent gloves and intelligent coats and jackets. Embedded sensors could monitor everything from your posture to your digestion, helping you make just the right adjustments to avoid back pain. And so I would like to say that these technologies are, and this great promise, are enabling changes to our lives. And this is enabled by three interconnected fields. We have robotics that puts computing in motion and gives machines the ability to move. We have AI that gives machines intelligence in making decisions. And then we have machine learning, which aims to learn from data and make predictions on data. And in the future, any fields that have data can stand to benefit. And I'd like to give you a very quick example of how humans and machines can form much improved teams than humans working alone or machines working alone. And this example is in the context of healthcare, where in this experiment, doctors and AI systems were shown scans of lymph node cells to diagnose cancer. On its own, the AI system had an error rate of 7.5%, which is worse than the 3.5% rare rate of error for the human pathologist. But when both the AI system and the pathologist worked together, the error rate went down by 80% to 0.5% accuracy. And so this is really quite extraordinary. Just imagine a future where every practitioner, even those working in small practices or in rural settings, had access to these kinds of systems. An overworked doctor may not have time to review every new study and clinical trial, but working in tandem with these systems, the doctor will offer patients the most cutting-edge diagnosis and treatment options. Now, there are a lot of possibilities, but then there are also a lot of challenges. And on the technical side, it is important to remember that today's greatest advances in AI are due to decades-old ideas that are enhanced by vast amounts of data and computation. Without new technical ideas and funding to back them, more and more people will be plowing the same field, and the results will be increasingly incremental. So we need major breakthroughs if we're going to manage the major technical challenges of this field. We also need to ensure a future where we can deliver data and computation like we deliver water and energy today with a simple turn of a knob. But now if we go a little bit more to look under the hood, we will see that first among the AI challenges is the data itself. AI requires data availability, meaning massive data sets that have to be manually labeled and are not easily obtained in every field. The quality of the data needs to be very high, and it needs to include critical corner cases for the application at hand. And if the data is biased, then the performance of the system will be equally biased. Two other things I want to highlight are that the current, or let me rephrase, most current machine learning solutions are black boxes, meaning there's no way for users of the system to truly learn anything based on the AI system's workings. And we also have robustness challenges. Now, we also have significant societal challenges, and while the spread of AI will make our lives easier, it's important to remember that many of the roles it can play will displace work done by humans today. So we need to anticipate and respond to the economic inequality this could create. Also, the lack of interpretability might lead to significant issues around trust and privacy, and we need to address these issues. We also need to consider how data can lead to misuses of the system, and in particular, as deepfakes get better and more widespread, the problem with misinformation will become more urgent for national security and for everyday applications. As we gather more and more data, the risks to privacy will grow, and so will opportunities for authoritarian governments to leverage the tools. And so we have a lot of challenges, but we also have a lot of opportunities. And when I think about challenges, I like to underscore that the problems aren't like the pandemic we're experiencing today. We know these problems are coming, and we can set out to find solutions at the intersection of policy, technology, and business in advance now. And we can begin by asking 5 important questions. What can technology do? What can't technology do? What should technology do? What shouldn't technology do? And what must we do? Because I believe that we all have a moral obligation to take these advancements in technology for the greater good. So with that, I will stop sharing and see if Jay-Z has a question for me.
Thank you so much, Daniela. And talk about sharing. What an incredibly kaleidoscopic overview, a snapshot of where we stand in late 2021, both with incredibly appealing and evocative visuals and with a summary of so many of the issues. And I think my only question before we turn to our next speaker has to do with how much you think we're in an equilibrium with the humans and AIs working together, say, in cancer diagnosis for a lymphatic tumor or what it might be, which is to say, isn't that AI accuracy asymptotically improving? And at some point, the doctor is just going to be clicking yes rather than offering their own distinct insight?
Well, yes, the accuracy of the AI systems is getting better and better and better, but that doesn't mean that we don't need the doctors. Because radiology is so much more than making a diagnosis based on a cell scan. And however, there is a lot of routine work that the AI systems can take on and really simplify and summarize potential challenges or issues for doctors. I also think that AI can be very good at noticing, at examining data and noticing patterns that are too subtle for the naked eye to see. And so while I don't think we're ready to offload control to machines, I think we stand a lot to benefit from having machines call our attention and provide suggestions to us, much like how we would use an intern today. Right? So we might ask an intern to go and pore over vast amounts of data and make suggestions to a decision maker for where to investigate more and how to think about the global picture.
Well, that indeed paints an optimistic one. And when thinking about the displacement of work or the complementarity to work, it's good to have an optimistic picture. And your first answer calls to mind Isaac Asimov's observation that anything that a machine can do is beneath the dignity of a human to be required to do as part of their work. They might choose to do it, but why
Well, Jay-Z, if you think about all the pains that many industries are experiencing today with hiring, then the issue of having machines, whether they are embodied like robots or whether they are computational tools like the AI systems we're talking about, that becomes to look quite appealing, I think. And to me, the excitement is the ability of offloading some of the routine tasks to machines so that we can focus on more creative thinking, on more interesting problems. And so it's all about building increasingly more capable tools that support people with cognitive and physical work. AI is really a tool. It's not any kind of magic. And by AI, I mean AI, machine learning, robotics. It's important to think of them as a trio. And just like any other tools, these systems are not intrinsically good or bad. They are what we choose to do with them. And I believe we can choose to do extraordinary things, while keeping in mind that there could be negative repercussions, and engaging in conversations like the ones we're having today to make sure that we avoid issues and that the benefits stand to benefit the greater good.
Thank you so much. More discussion to come. And by way of transition, I think also of Daniela's slide showing the arm trying to sort the two objects into the bins from a rear view of the human with the EEG sort of scalp attachment, which can evoke a kind of horrified fascination. But within that system then is a machine trying to glean the states inside the cranium of a person. And so who better to tell us a little bit about that next than Rana el Kaliouby, who is about not just reading the cognitive states, a yes or a no, but the emotional states of people, EEG not required. So Rana, over to you.
Thank you, Jay-Z, and thank you, Daniela. Very excited to be here with you all today and build on Daniela's work. So I've been on a mission to humanize technology by bringing emotional intelligence to our machines. And I first did this in academia. I did my PhD at Cambridge University, then came to MIT Media Lab. And then within a few years, spun out of MIT, co-founded my company Affectiva to be on this mission to bridge the gap between humans and machines. And very recently, we got acquired by a Swedish company called SmartEye that shares this vision and mission. So what is emotional intelligence and how does this apply to AI? If you take a step back and think about human intelligence, of course, our IQ matters, our cognitive intelligence, but our emotional intelligence, our social intelligence matters just the same. In fact, we know that people who have higher EQs tend to be more likable, they're more persuasive, they're able to motivate behavioral changes. And I believe that this is true for technology that is so deeply ingrained in our everyday lives. And AI certainly is. It's becoming mainstream. It's taking on roles that were traditionally done by humans. We saw some examples from Daniela's work. And this will continue to happen. And it's important that these technologies and these AI systems have IQ, but it's so important that we take a very human-centric approach to build empathy and emotional intelligence into these machines. So I've been on this quest, I guess, to build emotion AI. And to do that, I had to really dissect, how do humans communicate their mental and emotional states? And it turns out only 10% of how we communicate is in the actual choice of words we use. 90% is nonverbal, and it's split kind of equally between your facial expressions. You know, are you smiling? Are you frowning? Your body posture and body gestures, as well as your vocal intonation. How much energy is in your voice? How fast are you speaking? So if you combine all of these nonverbal signals, that gives you a really good picture of the emotional and cognitive state of a person. And you are then able to leverage this information to make all sorts of decisions. Humans do that all the time, to build empathy and to build trust, which is so much needed in our human-machine interfaces. The way you actually build a technology or algorithms to detect that is essentially a combination of using machine learning techniques such as deep learning. I personally did my PhD, over 15 years ago in Bayesian networks, so I spent a lot of time thinking about that. But all of this is driven with tons and tons and tons of data. You basically need to have hundreds of thousands of examples of people smiling and frowning and looking tired or excited. And then you feed it into say a deep learning algorithm, and then it learns over time to detect these human states. It can be quite challenging because humans are complex, and a lot of these expressions can be very subtle and nuanced. But we're making a lot of progress, and at the moment we're actually able to detect about 40 different emotional and cognitive states in real time. So what are the applications, you may be asking? We partner with 28% of the Fortune Global 500 companies in 90 countries around the world to help them understand the emotional engagement they have with their customers. So you can imagine a video ad or an online lecture where you want to understand, okay, were the students excited? I mean, think about, the symposium right now. Wouldn't it be awesome if, with everybody's consent, of course, I was able to see a real-time graph of the level of engagement of all of you, because we can't be together in the same room. So there's a lot of applications, everything from market research to online learning. And I wanted to give you a couple of examples. So I'm going to share my screen and share a few videos of some of the applications that we are focused on at the moment. So one of the applications we are very focused on is in the automotive industry. We're seeing a lot of legislation and safety regulations that are requiring cars to be able to detect if a driver is tired. We have 4 levels of drowsiness, everything from attentive all the way to literally asleep. And we've been collecting a ton of data over the last 4 or 5 years, and it's quite actually scary, the real-time behaviors we've been seeing in market. We've had to retrain all of our algorithms to detect people wearing masks, obviously, with the pandemic. We're able to detect your gaze direction to detect if you are, texting while driving or distracted. Body posture recognition, are you holding a phone? So combining that with object detection. And I want to point out that this is implemented in a car, but a car is only a robot on a wheel, right? And you can imagine, again, some of the robots that Daniela showed could definitely have emotional and social intelligence. And we're starting to see more of these social robots deployed in home, in retails, etc. We can detect multiple people. It doesn't just have to be the driver, and we can understand, combine face detection with body key point detection, and do things like gender, ethnicity, age, which can be very, very helpful information as well. And then, of course, we tie all of that with an understanding of the emotional state of the individuals in the vehicle. One of the key concerns I have, and again, Daniela kind of touched on this, is the importance of the diversity of the data, so that we avoid data and algorithmic bias. If we're training the data on a very non-diverse set of people, the algorithm is not going to recognize people who look like me, for instance. So that's kind of really key as we map out this machine perception pipeline. It's so important that we train and test with very diverse populations. So this is one example of how we are currently deploying this technology. This technology is already in about 500,000 vehicles around the world, and it's ramping up very quickly over the next few years. Another application that I'm very passionate about is in mental health. So when you walk into a doctor's office today, the doctor doesn't ask you, Jay-Z, what is your blood pressure or your temperature? They just measure it. We have sensors for all these vital signs. But in mental health, the gold standard is still on a scale from 1 to 10. How depressed are you? How stressed are you? How much pain are you in? It's very subjective. And we know that there are facial and vocal biomarkers for all of these mental health diseases. And given the fact that we spend so much time in front of our computers and our phones, that's an opportunity to, again, with people's consent, because that's really important. It's obviously very personal data. we should be able to build a baseline for every individual. And then when that individual deviates from that baseline, we can flag that to the person. We can nudge the person to change their behavior or get help, share it with a loved one, a clinician, doctor, etc. So that's an area where I'm very excited. I'm actually just over the last year with telehealth really accelerating. I'm seeing a number of startups in this area, and I'm excited to see where they go. And then one of the very first applications of this technology that we explored at MIT, even before we started Affectiva, was autism. As you may know, individuals on the autism spectrum really struggle with nonverbal communication, so much so that they will often even avoid looking at the face altogether. It's just too much information. And for kids, this really affects their ability to learn, their ability to make friends. And for adults, it affects their ability to get and keep jobs and also be in relationships. So it's a really key problem. And we are partnered with a company called Brainpower.
Mom.
8-year-old Matthew Krieger has been diagnosed with autism.
A lot of the trouble he gets into with other kids is he thinks he's funny and doesn't read at all that he's not, or that they're annoyed or angry.
Matthew's mother, Laura, signed him up for a clinical trial being conducted by Ned Sahin.
I want to know what's going on inside the brain of someone with autism. And it turns out parents want to know that too.
You get points for looking for a while, and then even for looking away and then looking back.
Sahin's company Brainpower uses Affectiva's software in programs Matthew sees through Google Glass. These games are trying to help him understand how facial expressions correspond to emotions and learn social cues.
One of the key life skills is understanding the emotions of others, and another is looking in their direction when they're speaking.
Looking at your mom, and while it's green, you're getting points. When it starts to get orange and red, you'll slow down with the points.
Am I looking at you?
You are looking at me.
Just a few minutes later, the difference in Matthew's gaze overwhelmed his mother.
I'm going to cry.
Why?
Because when you look at me, it makes me think we haven't really before, because you're looking at me differently.
So Brainpower currently has about 450 of these systems deployed around, with different families around the US. We're already finding that with the Google Glasses and this combination with Emotion AI, the kids are actually improving from their ability, to interact with others and read and understand these nonverbal cues. The key question is whether this is a learning tool or is it an assistive tool, right? Like if you take the glasses away, does the learning generalize and persist? And that's what they're actively exploring. But it's really, really powerful work. I often get the question, I am optimistic about this technology, but I'm not naive. I know that this technology can be used to discriminate against people. It could be used to profile people. We often get approached by various governments and also organizations that want to do lie detection or deception detection or surveillance and security. And we have taken a very hard stance that we are not going to engage in this use case and in these industries, even though as a company, we could probably drive millions and millions of dollars of funding and revenue. But I believe that, this technology has incredible opportunity to not only transform human-machine interfaces, but also reimagine human-to-human connections. And we've chosen to kind of focus our efforts and our mind share on that. And then even beyond our company, I'm a huge advocate for the ethical development and deployment of this AI. And I feel like, well, I know and I believe that one key component of that is ensuring that a diversity of voices and perspectives in terms of how we think about Emotion AI, its use cases, its applications, and again, where should we use it and where should we not use it? And I will end with that. Thank you.
Rana, thank you so much. Talk about a presentation that takes us on a journey, and I am pretty confident in predicting that those tuned in right now or watching later, if your software with consent was tuned to their emotional states, they would be fascinated and touched and perhaps a little timorous. And that's what you were kind of getting at the at your last your kind of concluding set of remarks, and talking about your awareness of the ethical implications of some of this. And I just wanted to ask a question to get at that a little bit, which is, your car example for tired driving is compelling. I mean, as somebody who teaches torts, I'm well aware of how amazing it would be to, through the tort system, ultimately have that be standard, kind of standard equipment on a car that would literally save lives from the day it was installed. And of course, when you're tired, you don't process that you're tired. You've got the Dunning-Kruger effect working against you, and the car is helping you out. But when you said 90% of our communication is nonverbal, my guess is that more than half the people tuned in, and I would be in that half, suddenly like straightened up and kind of like, what am I broadcasting that I don't mean to be? It doesn't have to be a poker game to want to be able to try to project an emotion that may not exactly line up with whatever is roiling inside of us. I think of the Duchenne smile, which is maybe a grin, but a kind of forced one that we might all be familiar with from our parents or whoever asking us to pose for a photo. So just, I understand your trying to keep a tight anchor on who would use the insights and the amazing technology you're developing. But just how would it be that 10 years or sooner from now, if we have things like Facebook Ray-Ban glasses, or in your video, Google Glass, that you just wouldn't have people, if not using your technology, using that of a competitor, able to walk down the street or sit in a conference room and have their Ray-Ban glasses on, and as they look at each person, they're going to know how that person is reacting to them and to others, and they'll get a lot of telemetry that otherwise would be theirs to figure out and to doubt.
Yeah, there are a lot of privacy and ethical questions with regards to where you can deploy this technology. I mean, we outside of even security and surveillance, we get a lot of requests to deploy this in retail stores from a customer experience, analytics or perspective. And actually, given that now a lot of meetings are happening online, right, on Zoom and Teams.
Make it a Zoom plugin or something.
Exactly, and you can now, for the first time ever, really quantify who gets airtime, who's speaking, who's cutting who off, right? And it's, on the one hand, I think it can be very powerful data, and if it's used in the right way, can be quite productive, actually, can be used to really enhance meetings and meeting dynamics and team behavior. But if it's used in a way to spy on people, then I'm against this. And I'll give you an example. In China, I have not seen this myself, but I've seen reports of it. In classrooms, apparently they're using this technology to detect if kids are fidgeting or not paying attention, and if they are, they get penalized, and they get reported to the head of school and their parents. And I'm thinking, this is an amazing opportunity to engage a student who is disengaged, right? As opposed to penalize the student. So same technology, very different ways of applying it. And so I guess Daniela said that too. Technology is neutral. It's how we choose to design and deploy the technology and the use case that's going to make the difference, whether it's really helping individuals or being used to hurt individuals.
And of course, just in a yes and sense, it regresses in part to the eternal question of who's the we making the decision. And if the we is a system rather than just people getting together to make a decision, what are the incentives of the system overall, which might be, you're saying millions of dollars could come your way if you weren't to have the scruples. Those millions of dollars are a demand looking for a supply that might come from elsewhere. I can't believe I'm backing myself into making an argument for strong patent protection, so that
and thoughtful regulation too, and thoughtful regulation.
Yeah. Wonderful. Thank you so much for such a provocative and moving talk. It's not often that you feel like you get a glimpse of the future and how different it might be, even in a quite short term. But every time you present, that's what you are presenting. Thank you.
Thank you.
So our third and final contributor for this panel, Ajay Agrawal. Thanks so much for joining us, and maybe for rounding out our tour as we think about the economics of AI and the ways in which AIs can make predictions that we might not be able to make, but that could prove accurate, and how to process that as people. So over to you. Thanks so much for contributing today.
Wonderful. Thank you very much. Nice to be here. Jonathan, thanks for the introduction. So I'm an economist, and I will take a slightly different view on this, or pardon me, different approach. And the way, and I should actually just begin by thanking the organizers for including me here. This has been wonderful to listen to Daniela and Rana both, learn something from each of them. And so the way economists think about new technologies is reasonably simplistic, actually, which is every new technology that comes along, most people think about a technology and are interested in how it works. They want to see under the hood. They're interested in how it's going to affect their life. Whereas for an economist, we look at new technologies and strip away all the complications and frankly, a lot of the fun, and reduce every technology down to a single question. And that question is, what does this reduce the cost of? So for example, in the case of the internet, economists studied that for a while and eventually, okay, we get it. This reduces the cost of search, reduces the cost of digitally distributing information, and reduces the cost of communication. In the case of the semiconductor industry, economists studied that for a while and said, okay, we understand this technology reduces the cost of arithmetic and makes arithmetic cheap. And so the same is true with AI. If you were to ask an economist, what is AI? If you ask a technologist, they would probably have an image like this in the back of their mind. And they would talk to you about advances in neural networks, and they would tell you about things like backwards propagation and gradient descent and things like that. If you were to ask an economist what's going on in AI, they would not have an image like this in the back of their mind. They'd have an image like this. And the reason that an economist would say this is such a profound technology is because the vertical axis represents something that is extremely foundational. It's something that is embedded in so many things we do. And in the case of AI, that thing is prediction. So the way an economist thinks about AI, it's about a drop in the cost of prediction, that AI is making prediction cheap. And so what does it mean when something becomes cheap? Back to economics 101, downward sloping demand curves. When something gets cheaper, we use more of that thing. And so that's the way we think about how AI will interact with people is as a prediction tool that becomes more and more ubiquitous because it is cheaper and cheaper to deploy. So what is prediction? You can think of this very simply as predictions taking information you have to generate information you don't have. So that includes all the things that you and I historically thought of as prediction, like, for example, in business, the data I have are sales over the last 20 years, and the data I don't have are sales in Q3 next year, and that's the thing I want to predict. But so is the data I have are all the pixels in the medical image, and the data I don't have is the label on the tumor as malignant or benign. That's also predicting the label on an image. And so what we began to see as we looked out is that many of the applications in AI, really, they fall into two categories from an economics perspective. There are everywhere that we're already using predictions, we just start using more of them because they're better, faster, and cheaper. So for example, in banks, everywhere they were already doing predictive analytics, like in fraud detection, anti-money laundering, sanction screening, now they're just using a new tool. They're taking out some of their older statistical tools and dropping in new machine learning tools. So that's category one. The other category is taking problems that we didn't used to think of as prediction problems and transforming them into prediction problems so that we can bring this new technology to bear. So for example, semiconductors, the canonical example that everyone's familiar with, one of them is photography. We used to solve photography with chemistry. So photography was a chemistry problem. And as semiconductors proliferated, became cheaper and cheaper, the cost of arithmetic went down. We eventually transformed photography to an arithmetic problem. And now we're doing the same thing with AI. As prediction becomes cheaper and cheaper, we take problems that we didn't used to think of as prediction problems and we transform them into prediction problems. Canonical example that everyone on this call is familiar with is, of course, driving. So we effectively are turning driving into a prediction problem. And so, the car, doesn't have our eyes and ears, so we give it its own sensory inputs, cameras, radar, LiDAR, and things on the outside of the car. And the way you can think about this very simplistically is the way we train the car is we put humans in the car, they drive for millions of miles, and the AI effectively begins to be able to predict when it receives some
I don't know if it's the AI blocking you, but I at least have lost your audio.
Oh, okay. Can you hear me now?
You are back.
Okay. All right. So I'm just effectively, I'm just describing driving as a prediction problem. Okay. And there are all kinds of problems that we didn't used to think of as prediction problems that we have transformed into prediction in order to use AI. Jay-Z, can you hear my audio still?
Yes, I can.
Okay, wonderful. And so these are all problems that we didn't used to think of as prediction, that we are addressing all of these as prediction problems. Okay, so that's my point number one, is just think about the cost of prediction dropping significantly. The second point here is judgment. And so we can take any task and break it down into these elements. So imagine if we were in person in Cambridge on campus, and I was giving this presentation, and as I was walking around, I bumped my knee, and on the lectern, a few days later, my knee's in a lot of pain, and so I go and see the doc. The doc probably asks me some questions. Maybe she sends me for an x-ray. That's input. She's collecting input. Then she makes a prediction based on the data she has. So maybe she says, okay, 90% chance that you've just bruised your knee, 10% chance it's a hairline fracture. That's the prediction. Then she applies her judgment. And you can think of judgment, one way to think of judgment is, what's the cost of a mistake? What's the cost if I treat this as a bruise, but it's really a hairline fracture, versus what if I treat it as a hairline fracture, but it's really a bruise? Think of that as her judgment. Then she uses her prediction and her judgment to reach a decision. Both the prior speakers use the word decision in their presentations. I think that's very central to our thinking about humans and AIs. And then, as let's say her decision is, okay, I'm going to treat this as a bruise. We'll put some ice on your knee and then come back in a few days. If it's still hurting, come back and see me. A few days later, I'm either all better, good to go, or I'm in more pain and I got to go see the doc. Either way, there's an outcome. I'm better or I'm not. And then we learn from the outcome, and that becomes training data. From an economics perspective, what we're interested in is that, people are talking about AIs coming and taking people's jobs, but AIs really are a substitute for one thing in this diagram: prediction. That's it. AIs substitute for human prediction. So in economics terms, as the cost of machine prediction goes down, it will push down the value of human prediction, because that's the substitute. But all those other things in this diagram are complements, and the value of complements goes up. So when the cost of prediction falls, the value of the complements goes up. So for example, the value of human judgment goes up, which is the value of what to do with the prediction. Just like I teach in a business school. In the business school 30 years ago, when people were coming to a business school, let's say they took accounting, they would get homework assignments of tearing out a page of the phone book. And for the undergrad students, the phone book was a thing that used to have the phone numbers of everybody, and you would go to the phone book to look up someone's phone number. And so they would go home and add up all the numbers in the phone book to practice their adding. And now, of course, we don't expect anyone to practice their adding when they come to business school, adding and subtracting. But what they do is they apply their judgment to the output of the calculations that are produced by their spreadsheet. So the judgment in terms of what to do with the predictions and how to deploy them, the value of that will increase. My last bit here is, what happens when judgment can start being predicted. I'm just going to show you some experiments that we're working on. I'm the co-founder of a company called Sanctuary. And so we make these humanoid robots, and the control systems are humans. And the main thing to keep in mind with our robots is that they are interacting with the world. And as the human pilots the robot starts to learn how to interact with its environment. And an increasing fraction of the duty cycle of whatever task it's doing, we can start predicting. And so what we're interested in is what fraction of the duty cycle can ultimately be taken over by the AI via prediction. So for example, this one's in berry picking. So right now, we've got a combination of human pilot control and an AI. And as we pick more and more berries, the AI is able to take over larger fractions of the duty cycle. And then whenever it gets to a point where it feels it does not have high confidence in its prediction of what to do next, it goes back to the human pilot and says, I'm stuck. Can you take over control? And just the last example I'll illustrate to you here is playing chess.
Let's play some chess.
And this is now in this chess example. I'm just going to show you what the human pilot is seeing, that display up in the top right corner. And so the human pilot is not a chess expert, but we're using a chess expert AI to guide the human, who is then moving the chess piece while they're playing against their opponent. And as we repeat the exercise, the AI is able to take over increasing fractions of the duty cycle in terms of the motion planning of moving the physical chess player's body.
Let's play some chess.
Let's do it.
So
I'm going to go first.
I'm going to just wrap it up there. We've written this book called Prediction Machines, The Simple Economics of AI, and the remarks that I gave today are from the book.
Wonderful, thank you so much. And if you want to put a link to the book into the chat room, I think as a panelist, you're entitled to do it for everyone, or maybe one of our organizers can do it. People can click their way to order it or to learn more about it. But just first a clarifying question. When you had your slide up of the kind of duty or task cycle, were you saying that prediction has been the realm of that's the one part of the AI, but now it can inhabit other of the circles? Or are you saying it's still confined to that one circle among the rest?
No, it's AI is entirely confined into the prediction circle. And so what the point I was making there is as we divide up the tasks into what's prediction and what's judgment, when we get enough examples of judgment, then that you can think of it as shifting over into the prediction column. That's now a thing that we can predict. And so if we get enough examples of a person applying their judgment of what the human would do in a particular case. So let's say we were given an example earlier, I think Daniela, she used the word suggestion or recommendation. And so in other words, she said, think of the AI as giving the human a suggestion or recommendation, and then the human, she compared it to an intern, makes the decision. Once the AI gives enough suggestions, and then the human makes the decision, and we get a feedback of what the human did with that recommendation or suggestion, then we can start predicting that too. And so yes, we can sort of kind of keep moving but it's always only predicting. It's never actually, it doesn't have, so far, we have no machines with agency.
But it might only be predicting, but this is kind of the thing I was clarifying, and you're right, the connections with Daniela's presentation are just terrific. But that prediction bubble is growing and growing. It's a dynamic bubble. The sphere of things that are candidates for accurate prediction is getting bigger and bigger, for which you need less and less of the surrounding ecosystem of bubbles to have the machine succeed in the world, yeah?
Yes, that's right. So in other words, when I was watching Rana's presentation, I was saying, okay, my interpretation of it was she started off with an AI that was learning to detect and predict when an eyebrow was furrowed. And then she and then she would, let's say at one stage, use that and feed that to a human who is then taking that label of a furrowed brow and characterizing that as some emotion of angry or frustrated or surprised. And then when it gets enough examples of that, where it combines the eyebrow furrow and other things, then the machine itself can go right to surprised. It doesn't have to, stick with those intermediate predictions.
And now, from a clarification question to like a question, if we end up seeing a bumper crop in the ability of AI to make meaningful and accurate predictions, might that be unevenly distributed? In other words, we're not just talking about, by metaphor, wealth, but income inequality. Could it be then that those in a position, because of the data sets they're starting with, or the kind of training they do, that creates a virtuous cycle so that their machines are out there and being purchased and learning more as they go, would it mean that predictions, accurate predicting, could be quite unevenly distributed, that many entities would be no better off than they were before unless they're in a licensing or other agreement with the entities that manage to make great predictions?
Absolutely. In other words, I would say that's the default. It's not like a chance. It will absolutely be unevenly distributed. And I think a great way to assess that distribution is, Daniela had a slide where it was titled something like AI challenges.
Yes.
Every one of those challenges that she had 6 of them on her slide. Every one of those challenges is a friction in terms of trying to generate robust predictions for an application. So if, no matter what your application is, you go to her slide of 6 things and say, how close are we to overcoming each of those 6 things? And the ones where, like, there's some easy ones that we've already done, where we're doing predictions, for example, for fraud detection in banks. They spent a lot of money on it. It was already well regulated in terms of how they would do this. So each of her 6 categories, they had the data, they had all the stuff. So that's that's a pretty far advanced application of machine intelligence is for that. Then you go to, autonomous driving, and all 3 of the ones on the bottom of her row, like she had 3 on the top, 3 on the bottom, those 3 bottom ones, the car industry is still, I would say, in reasonably early stages of trying to overcome those things. And so I think it'll be very uneven, but we can anticipate the unevenness by basically thinking through those challenges for each of the applications.
Got it. Now, even without the help of Affectiva, I think I have identified in Daniela's window a hand up and a desire to say something. Daniela, over to you.
So, yes, I'm eager to contribute. I would like to say that the challenges that we are grappling with today are due to our existing approaches, to our current methodologies, which I want to re-emphasize. They are due to decades-old technologies that are enhanced by computation and data. They're brute force methods that didn't work 10 years ago, but then all of a sudden work now because we have faster computers and we have more data. There are new ideas that the community is developing. Not every data item is equally important. There is the right data, and then there is the extra data that does not bring anything new in the training of an engine. There are machine learning methods that are unsupervised versus the ones that are supervised. And so my point is that we are making technological advancements that will make some of those questions disappear foundationally. And I will just give you a couple of examples. So I want to give you an example of reduction in size of a network. So most neural networks today are huge. They have hundreds of thousands for the small size, and we go up into millions and billions of neurons. Each neuron executes a very simple function. It's a function approximation. It's a thresholding function, but by putting together a lot of neurons and interconnecting them, we somehow get this magical behavior. Well, if you have a safety critical application, it's important to kind of understand how the network reasons to a decision. And we've been looking at driving as an important example of a safety critical application. And we have shown that we can learn to drive by watching humans, how they drive, using about 100,000 deep neural network nodes and about 500,000 parameters. But then we developed a new model, which we call neural circuit policies. These models are inspired by the natural world, by the neural structure of simple organisms, and by how biologists have completely mapped what that looks like. And so we can achieve the same task of learning from humans how to drive with 19 of our new neurons. But our new neurons are more powerful. They can compute liquid time differential equations. But now if you have only 19 neurons, you can get an explanation for the system. You can also have a more compact representation of the system, and this has implications on how you train the data. It has implications on the carbon footprint of the model, and it has implications on a lot of the different technical challenges. So the point is that, yes, we have some challenges that are making some industries get ahead of other industries, but there is a new wave of technologies that are coming, and I believe that in 5-10 years time we will have different tools that will help us in some sense equalize.
So in some ways, I think that sounds reassuring, and I think it's intended as reassuring because it's saying there will be things can't get too much out of sync among different industries or among particular competitors. Of course, it also suggests that within a few years, we really are going to see an explosion of new technologies and applications. And I guess maybe it puts it over to Rana as somebody who will, is an industrialist in these areas, as well as a critical thinker about these things. And I guess I'd love to know, Rana, when it comes time for which maybe is overdue, it's like now, to be thinking about what boundaries should be placed on the power of these systems, on the differential uses. You just change it by 5 degrees, and the incredibly salutary, heartwarming case you showed for autism could be applied to the example I think Daniela was talking about. I think it was Daniela, or maybe it was you, in China, of using the very same ingredients to gamify kids being more aligned with authority, all that kind of stuff. I guess here's the 64 Bitcoin question to me. To what extent is the prevailing Silicon Valley and general market-based ethos that says if it isn't prohibited, it's permitted? Basically, huge field, go out, innovate, transform, experiment, learn, and if there are problems, we'll catch up to them later. How much is this posing a challenge to that framework? And how much would you welcome the corresponding intervention by government, by some outside set of judgments, not just what you owe to your shareholders and to your conscience, in how to shape those technologies as they're still in their infancy? Again, it's hard even for me to say this as an internet person, because gosh, the development of the internet was so critical to have with that permissionless innovation. But I'm just curious what your temperature on that question.
Okay. Well, first of all, I don't think we should stifle innovation, but I think this mantra of ship it and then beg for forgiveness, I don't think that that's going to fly anymore. And I actually feel strongly that as leaders, as innovators, as people who are at the forefront of this innovation, we need to set the bar higher. So I'll give you an example. We decided a number of years ago to join the Partnership on AI Consortium, which was a consortium started by all the tech giants, Google, Microsoft, Amazon, Apple, Facebook, etc. But they also invited a number of startups, and we partnered with a number of civil liberty organizations like ACLU and Amnesty International. And one of the projects or initiatives we undertook was to outline all of the different use cases of emotion AI and proactively think about the unintended consequences. Like play it out, simulate it, and then imagine, okay, where could things go wrong? And then try to guard against it. That's very different. That's a very different approach than let's build, ship it.
Are the
And
fruits of that exercise publicly available?
Yes, there is. We published a white paper, actually. I'll have to dig it up and share it.
Yeah. But
we literally put a table together. Every row was a different use case. And then we had, okay, what can go wrong and what can we guard against it? And, we sat around the table with members of the ACLU who really challenged us. And I thought that was really interesting because as technologists and entrepreneurs, we don't often engage with the ACLU, right? We kind of try to just like proceed and kind of not really think about that. So I'm a huge advocate for thoughtful legislation and regulation, but I don't think as leaders we need to wait for that. We should set a very high bar and be proactive about these unintended consequences.
And that could even go so far as into product design. And I should say I'm working to synthesize a number of the questions that our audience participants have been asking. Thank you for all those questions. And a couple, perhaps, the observation that, technology is a neutral tool, it depends how you use it, is total catnip to the science and technology studies folks who are all up, no, technology is completely political. Design embeds values. But to the extent that that is true, does that mean you would welcome, a shadow over your designer desk while you're mapping out how the product's going to work that's trying to make sure that particular values get embedded in particular ways?
I actually really believe in defining a number of core values and using that not just as marketing fluff on your website, but using it to inform your business strategy. And so my co-founder is Professor Rosalind Picard. She's a professor at the MIT Media Lab. When she and I started Affectiva, we literally sat around her kitchen table in her house, 30 minutes outside of MIT. And we said, okay, there's going to be a lot of applications here. How are we going to draw the line? And we defined 3 criteria or core values that have informed our business strategy. Commitment to privacy, acknowledging this power asymmetry. We wanted users to get benefit out of sharing this data, and transparency, and kind of holding a really high, not making our technology a black box, but actually opening it up and explaining the nuts and bolts of it to the extent we can. So these core values have informed our business strategy. They're encoded in the design of our algorithms and our solutions. And I think it's important that whether you're an AI startup or you're a Fortune Global 500 organization implementing AI and digital transformation, that you be clear on these core values.
So I think that might put it back to our resident economist to ask, how do we avoid a race to the bottom, where if you've got people wanting to be responsible and really opening up in process and substance, but again, there persists huge demand for all of the fruits of this. And as Daniela points out, they can be done cheaper, maybe with less data, that it will be democratized. Don't worry about that, or it could be democratized. Are there any, looking at past history and other technological explosions perhaps, what are the prospects for being able to contain and set a playing field for it, rather than just have whoever's willing to not worry about this stuff is the one who gets the biggest market share?
Well, I think Rana had 2 elements to her response. One was the leadership of the builders, and the other was regulation. And it's hard to imagine the race to the bottom not having a very big effect on the first of her characterization. In other words, there will be people like her that will care a lot, just as there was in food, like there was the Ben and Jerry's and people that cared a lot about, you know, how the ingredients were sourced and what they did. And then there were people that, didn't care at all about that. And furthermore, there's a lot of, this is a field that's kind of attracted a lot of, probably because of the time it came into its kind of glory. There's a lot of attention to the sort of social justice aspirations of machine intelligence. And meanwhile, there's a lot of, I don't want to say bad actors, but countries with other objectives. And sometimes people say, well, we need to control AI like the way we control nuclear weapons, but we can't do that because the control mechanisms, the enforcement mechanisms we use for nuclear require on an ability to inspect and enforce. And we cannot inspect or enforce, when people can write code in their dorm rooms, and build models to apply against, all kinds of problems. So I think
that seems like a huge dilemma. I hope you're about to say, but here's how we can overcome that.
So it feels like when you say race to the bottom, it implies that there is only one direction. And so, I view this more as a, so first of all, we call it AI and it feels like there's something magic. Like, I think another way to do this is just call it computational statistics, which is what it is. And say, okay, so we're getting these advanced in computational statistics, and we got to make sure that the positive uses for this protect us as best as possible from all the negative. So I imagine this to be a constant arms race, like the one that we saw unfold in the Cambridge Analytica example. Like now we've seen it. So, if it happens once, then the key for us is to make sure that we don't let it happen over and over again. And so we know that's a thing. And now we are building all kinds of tools to protect against that. This is an area in your own area of expertise. So I think, you'll have views yourself. And so my view is you can't stop the bad actors here. And so it's just going to be a constant back and forth between our ability to protect against it and the people looking for routes around.
Well, I must say, to the extent that there end up excesses and problems, the fact that they arise from mere computational statistics is small solace. Understanding that the AI specter carries its own.
Well, the reason I wanted to just say that, JC, is because when people use the phrase AI, for many people it invokes a sense of agency, like as if the machine itself has imbued in it some nefarious objective. And so the reason I like to call it computational statistics is because then people realize the machine's not doing anything, only what it's instructed to do by the people who built it.
Yes, and that's to say too, to the extent we worry about these things, it might be a bit of a red herring to be fretting about artificial general intelligence and what happens if we have, a Terminator or something, and more, as you say, just about extremely powerful, potentially unprecedented tools of assessment and prediction, and ones that can scale up. I guess this is maybe back to Daniela, pretty quickly, especially once you have crossed the blood-brain barrier between bits flowing and processors flopping on the one hand, and stuff happening in the real world on the other. I mean, the videos you've all offered are so evocative because they have a tangible real world quality to them that includes, as Ajay was saying, the ability to learn by interacting physically with the world. And I don't know if that provides a potential gatekeeping point once it's escaped the mere platter or something. I don't know, Danielle, if you have thoughts on that, or any of you really.
Well, I think that it's really important to keep perspective. It's important to understand that today's technologies are not going to solve all of our problems, and they're not going to take down the world. If you're worried about robots and you think that your job goes away, I just want to ask you, where are the robots? Look on the street. How many robots do you see on the street? Are we
Well, yeah, but that chicken keeps saying, every day the farmer feeds me. They're my best friend.
So, well, okay. So I want to support what Ajay said. We have a lot of advantages from computation and from statistics. We already see how computers can do more than what we can. Machines can compute with higher precision than we can. They can look at game playing, and they can see more moves in advance than we can. And now we're just adding additional layers of sophistication in that process. So I actually don't see the machine that will take over the human intelligence coming anytime soon. I really like the way, and my friend Andrew Ng talks about this. Andrew says that worrying about machines taking over is like worrying about overcrowding on Mars. Someday in our distant future, this may happen, but this is so far in the future. It's not. It's really not worth worrying about it.
I hear you on machines taking over. I don't know how much that carries over to the dynamic application in a broad sense of applied statistics. And Rana, you're going to get the last word. We have to wrap in a second. And I also want to ask, as you make your last word, if you can quickly address the question, how do you feel about potential defensive measures that people might develop to prevent the use of emotional AI or effective AI, affective? You said masks were no big deal. You could sort of retrain on them, but I imagine there could be other attempts to make it make things more inscrutable.
Okay, I'll answer that, and then I'll answer that first. So when we started doing this work, both in automotive and in other industries, we got a lot. The first question was like, well, if I know that a camera is watching me, am I even gonna emote? And I'm just going to show you a 10-second video because I think it's just going to.
Oh wow, fast reaction. Yeah.
Okay, so this is a person who, with her consent, we asked to install a camera sensor in the vehicle, and it's tracking her daily commutes for months. And I'll just play it. So she has a phone in her hand, and she's texting while driving. She has a second phone in her hand. She has two phones in her hand. Eyes off the road.
And so your answer is like trying to take countermeasures. Good luck with that.
Exactly.
Well, wait. But the autonomy system can intervene and make it easy for her to do exactly that.
Exactly.
So we are developing exactly the tools that will make that behavior safe.
So I see. You're saying the autonomous car will intervene so that it's no longer a problem.
Exactly. Well, the Guardian autonomy system of the car. The idea being that the car could have a parallel autonomy system that will intervene to support the person.
Instead of using the AI to penalize texting, we can just use AI to make texting not something you'd want to penalize. I feel like we're only halfway through a wonderful dinner, and I would love to keep going, but we are at time. I hope we'll have a chance to continue this conversation in many forms, and with thanks for the many questions that I've tried to crystallize as we've gone along. But we are at the end of our session. We're going to take a short break, and I think the webinar is going to remain open, and there'll be like a holding slide on the screen. So For those out there, you do not need to sign off or leave the meeting. By now, you have probably put a burlap sack over your camera on your laptop or computer, and we respect that if that's the case. But the final session of today's symposium, AI Ethics and Policies, will begin shortly, so please stick around for that. And I know it will be a great panel, but I can't imagine the panelists having better backdrops in a room raider sense than any of the three guests we had today. Just perfect sort of framing. And thank you all so much for such a stimulating, inspiring, and indeed somewhat terrifying, but I look forward to being walked back a little bit on that set of thoughts and observations.